we have to do what to do. Oop, I never gave this brackets. How braces, sorry. How thoughtless of me. So now I can just copy basically all the stuff from what to do equals 1 and plop it in and change a couple things. Because we're not doing anything special. Leveling strength is just like leveling attack in this case, the way I'm going to do it. We are working on leveling strength. This is going to be a 2. Hope that makes sense as to why. Strength. And 2 right there. Ta-da! We're done with that. If what to do, that's Constitution. I'm just going to paste again. I'm going to make Constitution easier by taking out one of these zeros. So, Constitution is going to be 10 times easier to level than attack. Just showing you how you do that. I need to change this to a 3. Wait. Yes, 3. Had a brain fart moment. Okay, Constitution, like that, and stats, subscript 3. Also, we're not working on leveling attack, we're working on leveling Constitution. So, I'm not even going to run it to check to make sure those work, because I'm sure they do, because it's just copied code from what we wrote earlier. If what to do equals 5, that's the battle. This is kind of lengthy. This is actually quite a bit of code. And so let's get started. So, system.out.println, welcome to battle. Your chances of success depend on your stats. Then system.out.println, your stats are attack. And attack, semicolon space, plus stats 0, plus defense, plus stats 1, plus strength, plus stats, subscript 2, plus Constitution, plus stats, subscript 3. Long enough, right? And then system.out.println, would you like an easy, medium, hard, legend, or legendary monster? And then system.out.println, 1, easy, 2, medium, 3, hard, 4, legendary, like that. Now we are going to create a double called monster type. I should be consistent. Lowercase m. Monster type equals user input dot next double. So we're going to have integer monster stats is equal to 0. Actually, we don't need to set that equal to anything. Just define it. Then if monster type is equal to 1, then monster stats is equal to 10. If monster, and I know there are other ways to do this. You could write kind of like an algorithm type thing to do this for you, so that like whatever number they enter goes through an algorithm, like times 10. Divided by your monster divided by luck times you could do that, of course, in order to get the monster stats number. I'm just doing it this way. It's very straightforward. again, if I was making this for any commercial use or anything, I would include tons more stuff into this. Tons more skills. It probably wouldn't be. Why does it? Oh. It would have graphics and stuff. I don't know how to do graphics like that yet. I really would like to learn, and I will eventually. If monster type, kind of like they do in RuneScape, those 3D graphics like that. Okay, so then we defined the 4 different types of monsters, the 4 different difficulties of them anyway, and assigned monster stats values to each of them based on that number entered. You'll see what that does in just a minute with the way I'm doing this. So we're going to have an integer called constitution. We're going to set that equal to stats 3. Now you're probably saying, well, why would you do that? You could just do stats 3 for whatever you're going to do with the constitution. Well, with constitution, you're going to be battling, so I'm going to be subtracting from it what your constitution, what your health points remaining are, what your health points remaining are. Actually, maybe that's correct. Anyway, what your health points remaining, the value of them is. And so, because I know that's right, because values would be singular. So, in that case, it would be depleting your stats. And you see, when I write that next battle win, if you won, it would write to the file your decreased stats level, your constitution level. And you would not want that, and so we make a new integer called constitution, a temporary type integer that's not saved or anything, and not remembered next time the program runs or even next time you battle in the same instance of the program running, in which case constitution does not matter. It says it's not used, I know. I'm going to use it though. So we're going to do system.out.println, out.println, your opponent marches proudly into the ring. Good luck. So then we're going to have an integer array opponent stats equals new. It should be a length of 4. I know for the user I used 5, and you're probably wondering why I don't make it like the user, but the monster doesn't have to have a total battle count, like the amount of battles he's won, he or she has won. In which case, if we did, we would add one more to that, and maybe it would, say this monster has won X amount of battles, good luck, which would be just arbitrary made-up random numbers. But at any rate, that is not how this is going to work. I'm not going to have any amount of battles won for the monster, and so I'm just going to make the array 1 smaller for the opponent's stats. I'm not going to read those from a file. I'm just going to arbitrarily create them based on the monster type, monster status, monster stats. Did I type status? No, stats. Okay. So we're going to have a for loop for int I is equal to 0. I is less than opponent stats dot length I plus plus I plus plus. I could have also done 4 here, but I just figured in case we ever add another stat like, let's say, luck or something, we don't have to update this to 5. It's just automatically, it's smart enough to update because we updated this to 5. This is automatically updated to 5. So I'm going to do opponent stats subscript I, so that it starts at 0. So opponent stats subscript 0, which is his attack level, is equal to random.next int monster stats. See where that came in handy? Instead of putting a number here, oh, why does it? Okay, I guess we do have to initialize this just so that this can be happy, because it doesn't realize that this is going to initialize it. So I guess we will have to initialize it just to make this thing happy temporarily. It'll be happy forever, but it would be happy once it runs because it realizes, oh my god, look at these things, but it won't run because it's saying, oh my god, it's not defined. There's errors. We can't run. So, it really would work. If it wouldn't get mad at us about it, but it will because it's not clearly defined here, so we'll just do that right now. In fact, we could set that equal to anything. Not with an ER though, or not bigger than an integer number. It would just set it equal to 0. But so opponent stats subscript I, so that means then the next time it runs, 1 is added to I, so then I is equal to 1, so opponent stats 1, which would be his defense, random.next int monster stats. So you see what I'm saying? So if it's 10,000, it can have any random number for any of the stats, attack, strength, defense, constitution, up to 10,000. So it could have 1. A legendary monster could have a constitution of 1. It's just unlikely. It's more likely that it'll have a higher constitution. This is a purely statistics kind of based game. It's not like, if your monster is of type 2, so it's medium, then it has this many life points, this attack, strength, defense. No, it's random, generated, it's kind of weighted based on the difficulty of the monster. So it's certainly possible for someone with very low levels to beat a legendary monster if they in fact only had 1 constitution point, 1 attack, 1 defense, and 1 strength point, but that's extremely unlikely. It's unlikely. It's a 1 in 10,000 to the 4th possibility, aka not going to happen for any user on Earth who plays this game occasionally. More than likely, it probably won't happen. So anyway, I'm just going to move on before I blabber too long, which I think I already have succeeded in. So we're going to have an integer opponent constitution. I set that equal to opponent stats subscript 3. Integer your help equals stats 0 times stats 2, and this adds a nice kind of mathematical base to it. So now there's some strategy based on how your help is determined. You'll see where that comes in handy in just a minute. It's useful because now instead of getting your attack to 50 and your strength to 60, it would be more efficient because guess what? 50 times 60 equals 3,000. 55 times 55 equals 3,025. So if you had, you were able to level 100 times in the amount of time you have today, you would choose to level attack and strength. If you were trying to get your help as high as you could, you'd level those both to the same amount because it was more efficient. Because 50 times 60 is smaller than 55 times 55. Although 55 plus 55 is the same as 50 plus 60, so they both took as long to level theoretically. Obviously, if you tried it, you'd have different times because it's a random number generator that gets that. But if theoretically, that is how it would work. So we're going to have an integer also for your opponent help. Set that equal to opponent stats subscript 0 times opponent stats subscript 1, like that. And we're going to say, I'm going to show you the logical AND operator. So that is while constitution is greater than 0 and opponent constitution is greater than 0. So while both of you are still alive, essentially, integer e equals random.nextInt. The reason that I'm doing this is not because it's for use in the battle, it's to add a delay in between each time, in between each kind of round, in between each system.println of how many points of damage you have dealt and how many your enemies dealt and blah blah blah. It adds a nice delay. So int e equals random.nextInt 500,000, int j equals I say 500,000, I meant 50 million. And so while e is not equal to j equals random.nextInt, like that. Ta-da! And so it gives us that nice kind of random delay, as if, one of the times you might be kind of walking and dodging, and the other time you might be heading right into the fight. So it kind of gives also a sense of randomness. I mean, it's not like in RuneScape where, this exact amount of time you would take damage, every this exact amount of time your enemy would take damage based on your weapon and stuff. Which I don't have weapons included in this. That would be another cool thing to put in, but it'd be one more thing to add to it. And I'm trying to make this somewhat quick. I'm already on like almost an hour for this tutorial. So anyway, we're gonna do an integer called it's going to go in here, right after here. So we're going to integer your damage equals random.nextInt 100 plus your help minus opponent stats 1 is defense. So your damage is equal to a random integer between 0 and 99 plus your help, which is basically your attack, well, it is your attack and strength values multiplied together, minus your opponent's defense. We're going to do the exact opposite essentially for your opponent's damage, where it's, random.nextInt plus their plus opponent help minus your defense. So we're going to have integer opponent damage equals random.nextInt 100 plus opponent help minus stats subscript 1. Yay. So then we're going to do system.out.println you deal plus your damage plus points of damage to your enemy. And then we're